there, folks. Today we're looking at multiplying polynomials, and we're going to get into multiplying some of these larger versions of these things. You might be familiar with, or you should be familiar with, multiplying some of the smaller versions, like a binomial times a binomial. And so, again, multiplying polynomials, it's really just an expanded form of our distributive property, okay? And so looking at something like this, remember to use the distributive property with polynomials, we just have to distribute each term from one polynomial to each of the terms in the other polynomial, okay? And so the idea here is we just take each term one at a time and distribute it, all right? For example, if we look at something like these guys, I want to distribute each of the terms from one polynomial. So right here, I have two terms here. I'm just going to distribute each of them. I'm going to distribute the 3x to each of these. Okay, and really it's the equivalent to doing this. We're saying, hey, 3x times 4x plus 5. Okay, and when I distribute that, that gives me a 12x squared plus 15x. But now I go to the next term. I say, hey, let's take this next term, the negative 2, and let's distribute that. And you do have to distribute that negative sign with the 2, so I'm going to distribute the negative 2. Okay, and again, it's the equivalent saying, hey, let's take that negative 2 and do the same thing. I'm just doing my distributive property the same way I've always done it. Okay, and so I distribute that guy. That gives me a negative 8x. So let me write that in the other color. And a minus 10. Okay, and then the last thing I do here is I continue to simplify. I combine the like terms. And that's it. Okay, so again, it's just your distributive property. I like to say, remember using like the claw here. So when you draw those little arcs, it looks like a claw surrounding the one. But again, the idea is distribute each of those terms, okay? You might have had teachers refer to this in the past as FOIL. Do the first outside and then inside and then the last terms. The only reason I shy away from FOIL is because by the end of today's lesson, FOIL doesn't apply anymore, okay? FOIL doesn't work. But what always works is the distributive property, okay? If you always remember to take each term and distribute it to the next polynomial, you will get all of these correct. You will do all of them correctly. But FOIL only applies when you have two binomials, okay? And so if you want to remember it as FOIL, that's fine, all right? But keep in mind, that's not going to work by the time we get to some of these other ones, okay? Again, same thing with the next one. I'm going to take the x and distribute it. So I'm going to distribute the x. And I always write down those terms as I distribute. So x times the 2x is a 2x squared, and then the minus 8x. Now I'm going to distribute the negative 6. When I distribute the negative 6, that's a negative 12x and a plus 48. And I'll combine like terms. And as you get really good at these, most students can kind of skip that middle step and go right to this guy, okay? We can do that kind of combination in our heads, all right? If you're not there yet, that's okay, but it's something that you might want to work towards, especially with binomials, all right? With some of the more complicated ones, well, we probably don't want to do too much in our heads, okay? If I look at something like this guy right away, for these ones, FOIL no longer works, okay? If you were doing FOIL, it's time to abandon that for these questions, all right? If you did FOIL, let's see, here's the first terms. Here's the outside terms. Here's the inside terms, and here's the last terms. And notice that minus 7x hasn't gotten involved in any way, shape, or form, all right? So that's why FOIL doesn't work here. We just have to go to our distributive property. If we use our distributive property, say, hey, let's distribute the 2x, let's distribute this first term to everything in the second polynomial. So I have to distribute to the first term, the second term, and that third term, okay? And so let's write out this multiplication. So 2x times the x squared is a 2x cubed. Again, using our rules of exponents, we add the exponents when we multiply. Right here, that's a minus 14x squared. And then the 2x times the 4 is a plus 8x. Okay? Now I go to the next term and I do the same thing. I distribute it. So I'm going to distribute this negative 5 to all three of these pieces. Okay? I'm going to distribute to everything in the second set of parentheses. So negative 5 times the x squared is a negative 5x squared. Negative 5 times the negative 7x is a plus 35x. And negative 5 times the 4 is a minus 20, okay? And now, once again, I combine like terms. I have 2x squared terms. Those combine to a 19x squared. The x's combine into a 43x. And then the minus 20 doesn't have anything to combine with, so that's done, okay? But again, it's the distributive property. When you kind of think about what we've done here, if you kind of think of it this way, I took the 2x times that second polynomial. And you can break it down this way if you want to rewrite it like this, that is fine. And then I took the negative 5 times that second polynomial. I'm basically just breaking one of these up and distributing it individually, okay? And when you look at that, this distribution is right here. The second distribution is right here. It's the second 3 terms, okay? So I'm just distributing each term. The only reason I don't write it separately is I'm just trying to save a little space, save a little time. It's a little bit of a shortcut here, okay? Same thing with this one. Again, if you want to take it off to the side and write x times that second polynomial and do your regular distributive property, that's fine. If you want to write then 3 times that second polynomial separately, that's fine. I'm going to keep it together and say, hey, let's distribute this x. So I'm going to distribute that to all 3 of these, okay? It's like I'm just ignoring the 3 for a moment. And so I distribute that guy. That's a negative 2x cubed plus 6x squared minus 3x. And now I distribute the next term, the 3. So now I just ignore the x and say, if I just had a 3 out front, let's distribute it. Well, that would give me a negative 6x squared plus 18x minus 9. And now I look for like terms and I combine them. Okay, it stays the way it is. There, the negative 6x squared and the positive 6x squared and the minus 6x squared cancel. The x's add up to a 15x, and then the minus 9 kind of tags along for the ride. Okay? So again, distributive property. Take each term of that first guy and individually distribute each term to the second polynomial. Okay? If I look at this one, same kind of thing. I'm going to distribute this guy. And notice this is kind of written backwards. If you want to distribute the other way, that's fine. But you can distribute this way. And then I would say, okay, if I distribute that guy, that's a 12x cubed minus 6x squared. Now I'd have to distribute the second term. That's a negative 8x and a plus 4x. Sorry, negative 8x squared plus 4x. And then I still have to distribute this 5. So I still have to distribute that last term to each of those. And that's a plus 20x and a minus 10. Okay? A lot of students feel uncomfortable distributing that way. And that's okay. You can distribute the other way, or you can rewrite these. But if you want to distribute the 4x going this way, that's fine as well. Okay? And then distribute the negative 2 going this way, that's fine. Okay? You'll get the same 6 values that I have written right now. You just get them in a different order. But that doesn't matter because after we combine like terms, it's all going to look the same anyway. Okay? That's it. All right? Next one, same kind of thing. If you want to distribute backwards, that is fine. You'll get the same thing. So maybe I'll do that one this way this time. Okay? If I distribute backwards, I'll get the same values I would have otherwise. That's an x cubed plus 5x squared minus 6x. And I distribute that guy backwards. That's a plus 8x squared plus 40x minus 48. And then combine like terms. And again, if you want to distribute the other way, it's fine. You'll just get the same terms in a different order, okay? But that doesn't matter because we're going to rewrite it as we combine like terms anyway, all right? Taking a look at more than 2 polynomials here. So if I have 3 polynomials being multiplied or 4 polynomials being multiplied, let's see kind of what that looks like, all right? So you can only multiply 2 things at a time, all right? And that's true anytime we have 3 things being multiplied. If I had something like 2 times 5 times 3, we have to do only 2 things at a time. Like if I wanted to multiply those, I would do the 2 times the 5 and get a 10 first. And then after I was done doing that multiplication, now I would multiply the 2 things that I have left and get a 30. Okay? And it's the same idea here. I can only multiply 2 things at a time. And it's the same with polynomials. So I multiply 2 of the polynomials to see what I get. It gives me a new expression. And then I multiply that new expression by the next polynomial. Okay? I have to do it in series. I multiply 2 of the things together, see what I get, and now see what I have left to multiply and do that multiplication. For example, if I look at something like this guy. Again, I just picked 2 of these to multiply. I can only multiply 2 at a time. So if I were to kind of just ignore that guy for a second, if I only multiplied the first 2 together, well, it would look like this. I would distribute the x, okay? And that would give me an x squared plus 4x. I would distribute the negative 1 And that would give me a minus 1x minus 4. And then I would combine like terms, and I would get x squared plus 3x minus 4. Okay? And now here's the thing. It was that, okay, these first two things, times the x plus 3. So now I'm back in the same situation that I was in the previous couple examples, okay? I multiplied those first two things. Well, now I still have two things that I can multiply. So let me erase this guy for a second. Let's go ahead and distribute here. And so distributing this one, maybe I'll distribute backwards, okay? That makes most students feel comfortable. So let's see, that's x cubed plus 3x squared minus 4x. And then I distribute the 3 to each of these. And that gives me a plus 3x squared plus 9x and a minus 12. Okay? Now I can combine all the like terms. And I'm done. Okay? What I can't do is I can't take that first polynomial, the x minus 1, and distribute it to each of the other two polynomials. I can only multiply two polynomials at a time. Okay? So I have to focus on two of them, multiply those out, and then after I'm done simplifying, see what polynomials are left and continue to multiply two polynomials at a time. Okay? If I look at something like this guy, same kind of thing, I just have to remember that when I have something like this, something squared really means I have that thing times itself. So it's an x plus 4 times x plus 4, okay? And so as I go to multiply this out, I have to choose two things to multiply. I always like to multiply the binomials first. That's just me personally, okay? So me personally, I'm going to multiply out the x plus 4 times the x plus 4 first. You could do the x plus 4 times, that first x plus 4 times the 3 first. So you could just distribute the 3, okay? But again, make sure you don't do this. You cannot distribute the 3 to each of those and each of these, because now you're doing 3 polynomials at once. You can only do 2 at a time. So what you could do is just this. Okay, you could just distribute that 3 and see what you get. And then after you're done that, you could continue to multiply. Again, I like to multiply the polynomials first to get the big stuff out of the way. So here, I'm going to multiply the second 2 polynomials. And I can do it in any order I want because this is multiplication. Multiplication can be done in any order. So I pick whatever 2 I want to multiply to start, okay? And so this one, I multiply the x plus 4 times the x plus 4. I'm using my distributive property. That's going to give me an x squared plus 8x plus 16. And yeah, I did that quick little step in the middle in my head. I said, hey, the x times x is the x squared, the 4 times 4 is 16. But now think about those middle terms. I kind of kept this in my head. X times 4 is a 4x. Here, 4 times x is a 4x. Together, it's an 8x, okay? And if you're not ready to do that step in your head, that's fine. You don't have to do that step in your head. Take it off to the side, write your 4 terms, combine like terms, okay? And now I'm going to distribute that 3 to each of these guys. This is just my regular distributive property. That's a 3x squared plus 24x plus 48. Okay? Done and done. If I look at something like this guy, I've got 3x minus 2 cubed this time, all right? Which means I have 3x minus 2 times 3x minus 2 times 3x minus 2. One of the most common mistakes students make on these binomials, squared or cubed or whatever, is they just raise each of those things to the third power. You can't do that. You have to multiply that thing 3 times. So I have to write it out like this, okay? And so now let's distribute. I'm going to distribute these first 2. So I distribute the 3x and I distribute the negative 2, okay? So ready, here we go. 3x times 3x is a 9x squared. And now I'm going to do this middle one in my head. Ready? 3x times negative 2 is a negative 6x. A negative 6x in my head. Negative 2 times the 3x is also a negative 6x. So I have 2 negative 6x's, so that's a negative 12x. Okay? That's me doing it in my head. If you need to write out the negative 6x minus 6x, that's okay. All right? And then the negative 2 times the negative 2 is a plus 4. Okay? And now I have a trinomial times a binomial. I can go ahead and do my distributive property again. Let me clear out that little space. Again, if you want to distribute backwards, that is okay. And I'm going to distribute the negative 2. Okay? So here, when I distribute the 3x, that gives me a 27x cubed minus 36x squared plus 12x. Now I distribute the negative 2. That's a negative 18x squared plus 24x minus 8. And now I combine like terms. Done and done. Okay? So again, just multiplying these out, two things at a time. I multiply two things, I simplify, I multiply what's left. Okay? If I look at something like this guy, I have three polynomials being multiplied, all right? And so I'm going to start with the two binomials. I'm going to combine those. So I'm ignoring that trinomial at the end. I'm going to distribute here. So I'm going to distribute the 3x and distribute the negative 4. Okay? Once again, I'm going to try to do this step in my head. So 3x times x is a 3x squared. And then these middle terms are the ones that are going to get added up. So ready, 3x times a negative 7 is a negative 21x. Negative 4 times x is a negative 4x. So now I have a negative 21x and a negative 4x. That's a negative 25x. Okay? That's how I do it in my head. And then negative 4 times the negative 7, that last piece is the plus 28. Okay? So again, I'm using my distributive property. And now I've done that with those first two. Now I have a trinomial times a trinomial, okay? And this is beyond what we've done previously, but again, it's still just my distributive property. If I understand the distributive property, I'm distributing each of those pieces. So I'm going to distribute the 3x squared to each of these, okay? And I'm not going to draw the rest of it yet, so let's see. Let me distribute the 3x squared. That's a 3x to the 4th plus 3x to the 3rd minus 24x squared. Okay, so that was just the first term. Now I got to do the next term. I have to distribute the negative 25x to each of these. Okay, when I distribute the negative 25x, that's a negative 25x to the 3rd minus 25x to the 2nd plus, looks like a 200x. Okay, and yeah, the values are a little big, and that's okay. All right, you can use your calculator if you need to. But now I still have that other term to distribute. Okay, and that's the thing that I think students find tricky about distributing a trinomial is this guy right here, the 28 still has not been distributed, so I still have to distribute that 28. And if it helps, erase some of these other guys. You erase some of the clutter that's there and say, okay, let me distribute this 28 now. Okay. And hopefully that makes it a little bit easier just from looking at it, okay? These are the kind that maybe you want to take it off to the side, and maybe you wanted to do, 3x squared times the x squared plus 8x minus 8. Maybe you want to do each of these separately off to the side, okay? Because that's all we're doing. It's just a distributive property 3 times. And if it helps to just separate those out and take it off to the side, well, that's okay. Go ahead and do that, but then don't forget to take all the terms and write them together when it's all said and done. So here, that's a 28x squared plus 28x, and then, minus a 224. Okay? And again, if you did them off to the side, if you did each of these separately, that's okay. That's the first guy. That's what the second guy would give you. That's what the third guy would give you. Just make sure you bring them all back together at the end. Okay? And now I combine like terms. And there's quite a few here. It might help to mark these as we write them down. Start with the biggest. Always work your way down. So I start with the to the 4th power. That's a 3x to the 4th. And now with the x to the 3rd powers, there's one here, and when I combine those, that gives me a negative 22x cubed. And now I look for the x squareds. There's 3 of those, actually. One here, and one here. And so as I combine those, it looks like it gives me a negative 21x squared. And then I look for the x's. Let's see what I got here. 200x and a 28x. That's a 228x. And then the minus 24 is nothing to combine with, stays the way it is. Okay? But again, distributive property, that's all it is, okay? And when we're dealing with polynomials, it's just the distributive property for each individual terms. I distribute the first term, I distribute the next term, I distribute the next term until I run out of terms, and then it's about combining things, okay? When I have more than 2 polynomials, I just have to make sure that I do 2 at a time, all right? Multiply 2 polynomials, see what you get. See what you're left with. Now, choose 2 more polynomials that you have left to multiply. Okay? And again, as you multiply them, we distribute each term. Okay?